want to talk about today is a proposal that Eric and our college wrote national in December that builds on the research that we presented at the working group meeting last spring and that was published in American Antiquity in January, which looks at the multi-decadal variability in precipitation in the northern Colorado Plateau and how that plays out in relationship to intensification cultural in this kind of northern periphery of the American Southwest on the northern Colorado Plateau. So our work builds on that by asking some really fundamental questions about the nature of community formation and duration during this time period. So I'm not going to present any new data. I'm just going to run through really quickly the proposal as we've set it up. We learned last night that we did not receive funding for the proposal, so we will make those revisions and submit it again in July. We got some really good feedback, but so this is still very much in the development stages. Let's see. My computer will behave. Okay, so just setting the stage here. We're working in northern Utah, and this map on the left shows the prehistoric farmers of the Southwest. And I kind of like this image because the Fremont northern Utah, and this is really kind of the far edge of northern or of maize agriculture in Western North America, as diffused out of Mexico and up into the Four Corners region of the Colorado Plateau, where there's been a huge emphasis in understanding the nature of the social dynamics of farming over the last several thousand years. The cartoon on the right just kind of gives you a sense of these Fremont lifeways. This is very much a transitional forager farmer economy. Maize agriculture starts in this region about 2,000 years ago. We see it up into our study area about around AD 300, when we start to see the first direct dates on maize macrofossils in this particular area. So this map just shows the general distribution of the major Fremont archaeological sites in Utah in particular, and the red line indicates a with this Wasatch Front just to the west of the line, and Salt Lake City being right here, just in the kind of on the southeastern corner of the Great Salt Lake. Archaeologists have made some just kind of fundamental observations about the archaeological record here. There's some debate about the nature of intensification of maize agriculture and the reliance on maize agriculture. I think generally we can say as you get further north and further west, there's less of a reliance on maize agriculture and more of a mixed foraging farming strategy than there is in this Wasatch Front and Colorado Plateau area, generally speaking. But the basic observation is that communities in the northern Colorado Plateau seem to form earlier and last for shorter durations of time than the communities out here on the edge of the eastern Great Basin, which seem to form later and last longer. And so we're curious about what the fundamental mechanisms are that's driving that particular observation. So we begin with again, just another really simple observation, which has to do with the nature of the geomorphology of the eastern Great Basin compared to the Colorado Plateau. And I've just showed a couple of aerial images to give you a sense of what that looks like. This is the dry fork of Ashley Creek in the Uinta Basin, where we were at last summer or late last spring for the working group meeting. And what this illustrates is very much the entrenched canyon country of the Colorado Plateau and the restricted throughput of moisture or precipitation through the canyons of of these Colorado Plateau systems compared with the basin systems, which are much more driven by large alluvial fans, and it's a much more dispersive environment, right? So basically, what we see is at the mouth of each one of these canyons is a large alluvial fan. You get these broad coalescing alluvial fans out across the margins of these uplifts that form bajadas. Very classic basin and range style topography, where people throughout Western North America were concentrating agricultural efforts, catching the precipitation runoff as it's coming out of these canyons and growing along the floodplains. So there's two very fundamental differences in the way that moisture and precipitation moves through these geomorphic systems. Okay, so just a couple of observations. One, physiographic characteristics and precipitation combine to make communities more or less vulnerable to environmental change, right? So really we're talking about the stability of geomorphic systems as the ability of early agricultural communities to form. The second observation is that individual drainage basins are differentially sensitive to catastrophic change, right? So we're really interested in what drives the stability of these floodplain systems where people tend to choose to cultivate maize in these early agricultural systems. And when we're talking about catastrophic change, we're talking about arroyo formation. And what we know throughout the Western North America, the Western United States in particular, is that the current trend of arroyo formation initiated sometime in the late 19th century. There's been a lot of debate about what drove that. Originally, people thought that it had to do with land use change related to overgrazing of cattle. But as we've gotten a better understanding of those things, it seems to be much more linked to changes in the delivery of precipitation and increased precipitation over the last 120 years. But the one thing that we do know for sure is that as these arroyos form, they're very rapid events. So you might find yourself on a floodplain 1 year, and then within 3 to 5 years, the stream can be as much as 15 meters entrenched into the floodplain, and you no longer have access to that floodwater farming. So that's a major catastrophic event to an agricultural system. Our working hypothesis is simply that early agricultural communities that form in low sensitivity drainage basins grew larger and lasted longer than communities that formed in higher sensitivity basins. So we're looking at relationships between basin sensitivity and community duration. This is the kind of the core of our proposal. Just wanted to illustrate to you guys that kind of the three work packages that we've proposed and how they work together. Our colleague Justin DeRose is a dendrochronologist. One of the strengths of the long tree ring reconstructions that we have for this region that go back 2,000 years, and we've proposed to develop some more, is that we can convert precipitation into a streamflow reconstruction. We've created what we call the sensitivity analysis pathway. So this is a GIS-based analysis that looks at a series of, so we've chosen 6 communities to examine, 2 in the Northern Colorado Plateau, 2 in the Eastern Great Basin, 2 in this transitional zone. We begin with a basin sensitivity analysis that looks at some fundamental geomorphic factors of stream power, ruggedness of the landscape, and then a combination of discharge and ruggedness into what's called the hypsometric integral to categorize basins as low sensitivity versus high sensitivity. In essence, from a geoarchaeological perspective, we see channels that are dominated by side valley alluvial fans, so fan-dominated channels, versus flood-dominated channels. This essentially characterizes this upper pathway is more of an Eastern Great Basin or basin and range style. And this lower pathway is a much more specific Colorado Plateau style. So what we would then propose to do is create these long-term streamflow reconstructions for several communities throughout the study area, model the geomorphic conditions, use high-density radiocarbon dating focused on short-lived annuals to build Bayesian occupational models for the site, for these site occupations, and then pair those with local geoarchaeological reconstructions. So that's kind of the proposed plan. And it ties together something like this, right? So this is all fairly kind of standard dendrochronological information, but basically illustrating that there's a relationship between precipitation and stream discharge. This B shows that there's a seasonality of discharge in this particular area. So we see most of our peak runoff events in April through June. Again, if you were with us last spring, early summer in vernal, it rained for the better part of 5 days while we were in vernal. One thing that you can say for certain about agriculture in this area based on climate is that if it's raining this time of year in the basins, it's snowing in the mountains. And the longer that snowpack stays on, the longer you'll have a good, reliable water source into those critical summer months. But it also means that the more quickly that snow melts, the more catastrophic the discharge event is going to be. So you're kind of running some risks when you're farming on these floodplains. We're looking at long-lived tree ring samples. So Justin is, one of the things that he's been pushing is juniper records. Juniper has largely been discounted by a lot of dendrochronologists because it has a really funky growth pattern. But essentially what we can do is, just tease our way through these juniper records, tune that to the instrumental record, and then create essentially a reconstructed streamflow discharge for the last, ideally 2,000 years, because that encompasses our the window of time that we're interested in. We then propose to use the posterior probability densities of the Bayesian models for archaeological site occupations as a way to test periods of change in stream flow and potentially catastrophic events that we can observe also in the geoarchaeological record. So that's essentially what we have proposed to do. We got pretty good feedback. We're confident in our ability to hopefully receive funding for this. It will be for us a very ambitious dating project, the environmental proxies, and doing some geoarchaeological field work. So just to kind of tie it together, some of the broader impacts that we spoke to in our proposal, these come directly from the Kintig et al. 25 grand challenges in archaeology, and these are really very consistent with our objectives for the People 3K networks.